Let us start with the understanding of rotational motion. When we just talk about rotational motion, we can say it is the motion of a rigid body about an axis of rotation such that different particles of body move in different circular paths with all the centers lie on the axis of rotation. Circular motion you have already studied. When we talk about rotational motion, in rotational motion, different particles of a body move in different circular motions in such a way that all the centers of circle lie on the axis of rotation. Say for example, we consider a random shaped body which is pivoted on a given axis like this. So if there is an axis of rotation about which the body is rotating, in this situation, if we consider a small particle of the body, say this particle P, which is located at a distance r1 from the axis, then in the revolution of this body, this P will revolve in a circle of radius r1. If there is another point Q located on body, which is at a distance r2 from the axis of rotation, then during revolution of body, this Q will revolve in a circle of radius r2. So we can say all the particles of the body revolve in different circles with center of all lying on the axis of rotation. This is the motion of rigid body we call as rotational motion. Before proceeding further on rigid body dynamics, let's talk about the sections which we need to cover up in understanding of rigid body dynamics. The very first point we are going to start is with moment of inertia. Like in translational motion, we talk about inertia which is accounted by the mass of an object. In rigid body dynamics, the similar property is moment of inertia. Next is Newton's second law for rotational motion. In case of translational motion, we have studied about forces and Newton's law, like force equals to ma, action reaction law, as well as the inertia law. Mainly in rotational motion, we study about Newton's second law after moment of inertia. Next point we talk about is angular momentum and its conservation. Like in translational motion, we have studied in depth about translational momentum of an object and conservation of momentum. Similar to that, for a body which is in rotational motion, we define a similar parameter that is called angular momentum. So here we talk about angular momentum and law of conservation of angular momentum. The next characteristic property related to rigid body dynamics we'll study in the section of kinetic energy in rotational motion. Like in translational motion, we know that the kinetic energy of a body can be written as half mv square. Similar to that, in rotational motion, we define kinetic energy, and right after that, we'll talk about work and power in rotational motion. Here we'll also talk about work energy theorem for an object in rotational motion, similar to the situation we have studied in translational motion. And the last point, which is quite useful in such cases, will be different from translational motion, that is rolling motion and its applications. So these are the sections we'll cover up in the section of rigid body dynamics. So one by one we'll pick up all these points as well as we'll take up various problems based on the concepts we are going to cover up.